Hello guys, guess what? In this class, we're going to start something very beautiful as we go together and look into what is called your chemical and physical changes. If you are excited, give me thumbs up. Yeah, let's go. Now, in your physical and chemical changes, of course, we're going to start our lesson 1 and then we're going to flow together very quickly. Are you ready? Yeah, let's go. So what are we going to focus and learn here? We're going to learn the total of 4 powerful things. 4. And the 4 things include the following. Number 1, I'll tell you what chemical changes are, give you their examples and all of that. Inside all of this, you see the exam questions they have ever asked, what they will also ask. And then we go into your physical changes. And then we go into the differences between your physical and chemical changes. What are the cardinal differences that we should know? And thereafter, we're going to rock what? Past questions together. If you're excited, let's move. Let's start at first. The first one is chemical changes, right? Oh yes. So in chemical changes, the big question is, what are chemical changes? Very simple. Tell us this, that chemical changes refer to any transformation that results in the formation of new chemical substances. So those transformations that leads to the formation of new chemical substances, what are they called? They are called chemical changes. For the last time, what are chemical changes? Chemical changes refer to any transformation that results or give birth or rise to the formation of new chemical substances. They are called your chemical changes. And also, you must know that at molecular level, they involve the making or the breaking of bonds between atoms. In other words, chemical changes are the ones that result to bond breakage and bond formation. In other words, for a new chemical substance to be formed or a chemical compound to be formed, there is need for chemical breaking or bond breaking as well as bond formation. And what brings about that? It is only chemical changes that can produce that, not physical changes. So stay tight, open your ears, and let's go together. What are the examples of chemical changes? This is where questions are loaded. The examples of chemical changes, I'm going to give you about 20 of them. Are you ready? Yeah, let's go. They include the following. Number 1, it is called iron rusting. What is it called? Iron rusting. First, you must note that iron reacts with oxygen or air, right? Oh yes, so iron has the capacity to react with oxygen, which is your air, or moist air or aerated water. Any of these things that you see, that's the answer. So in iron rusting, what happened? Iron, right, with being a metal, has the ability to react with your what? Air or moist air or aerated water to form what? Iron oxide. And that iron oxide is iron trioxide. That iron trioxide is what we call what? Rust. In other words, when iron react with oxygen, see, iron must be there and it needs oxygen in the presence of what? Water. Are you getting it now? What is it going to form? It's going to form iron trioxide. What type of iron trioxide? Hydrated iron trioxide. So for rusting to occur, listen carefully. Number 1, you need iron. Number 1. Number 2, you need what? Oxygen, which is air, right? And number 3, you need what? Water. Which component of air is picked out? Oxygen is what is picked out from there, and then you need water. That's why it is going to form hydrated iron trioxide. So we can say rusting is the formation of iron trioxide. But what type of iron trioxide? Hydrated iron trioxide. That's what we call your what? Your rust. So number 1 example of chemical change is iron rusting. Number 2 example is what we call gasoline burning. You know your normal gasoline now, right? Like your petrol, your kerosene. What happens when you burn your gasoline? When you burn gasoline, combustion is burning, right? So the combustion or the burning of gasoline will always give rise to water vapor and carbon dioxide. Carbon dioxide is also called what? Carbon dioxide. So anytime your gasoline, this guy here is an hydrocarbon. And which hydrocarbon is that? That is octane. When octane is burnt in the presence of oxygen, what will it give rise to? Carbon dioxide and water is what it's going to bet. So number 2 example of chemical change is called your gasoline burning. Number 3 is what is called your egg cooking. How is it that you take your normal egg at home, you decide to boil it? When you boil it and you break it, it's now hardened. But the normal egg that you carry, once you heat it, it will break and then it's not hard, right? Yeah, it's just pour as liquid. But when you break the boiled egg, it's now hardened. Can I use my normal raw egg and convert raw egg? Can I convert my cooked egg back to my raw egg? It's not possible. Right? So boiling of egg, is it chemical change or it is physical change? Of course, it is chemical change. Why is it so? It's so because heat that you are applying to it during that boiling, it causes that fluid protein molecules to undergo what is called denaturation and coagulation. Two things: denaturation and coagulation. Denaturation and what? Coagulation. And what is causing that? It is heat. The protein in egg, which is in the fluid format, right? If you apply heat to it, what will happen? It will become denatured, and that's why it will become what? Solidified. And that's a good example of your chemical change. Number 4 is called your bread rising. What is it that makes your bread to rise? Right? What makes it to rise is your what? Your yeast. All they need is yeast. So yeast ferments carbohydrates into carbon dioxide gas, which is your carbon dioxide, and that is what causes your dough to rise. Have you seen where they are producing bread before, where they will carry your flour and then other different substances and then they mix them together? What you give birth to is your dough, right? What will make that dough to rise is the presence of yeast, and then you now go and put it in the oven, and then you now have your what? Your big bread. Are you with me? Now, what happens is this, very, very quickly. Let's go. This guy here is your carbohydrates, right? Yes, carbohydrates. And this guy that you are seeing here is more like your ethanol. And then this is your what? Your carbon dioxide. This is what causes your bread to do what? To rise. Number 5 is called milk souring. You buy milk, and the milk have hit the expiry dates, and then the milk gets stale. Is it stale or sour? Sour. Now the big question is this: can you convert that sour milk back to fresh milk? No, because souring of milk is what? Chemical change. Now this is it. Bacteria in that milk is what converts lactose into lactic acid. Hold on. I told you something about MLS, maltose, lactose, sucrose, right? These 3 of them, they are disaccharide. Bacteria will convert lactose into lactic acid, and the presence of that lactic acid is what makes the milk to sour, and that's what gives the milk the sour taste that you observe. In other words, this guy that you see here, this guy, what is it? Lactose, right? Now, lactose is now being acted upon by bacteria, causing more like addition of water, and then it will give rise to your lactic acid. The presence of lactic acid is what gives that sour taste. So milk souring is an example of your chemical change. Another example, we are going all the way to 20, is called your sun tanning. Sun tanning, sun tanning. What do we refer to by sun tanning? Follow me very quickly. Exposure to sunlight. What does it produce? It produces vitamin D and melanin in the skin. So anytime your skin is exposed to sunlight, especially this early morning sun, what does it generate? Vitamin D and what? Melanin. And that process is called sun tanning. Now this is it. What happens is this: your 7-dehydrocholesterol, right, in the human body is what's going to produce your what? Your vitamin D, right? And then reacting with your thyroxine, it will give birth to your what? Your melanin. So please, sun tanning is an example of your what? Your chemical change. And then another example is called your burning matchstick or wood. Hold on a bit. The complete series of classes, right, as far as your syllabus is concerned regarding your Jamb And Waec, everything has been covered in details for you in the LearnLifts app. And guess what? The sweet part is that you have access to your CBT, right? You have access to your video lessons. You have access to your notes. You have access to your past questions. Everything from the beginning to the end is directly in the LearnLifts app for you. So all you have to do is just mark down to Play Store or App Store and download the Learn Lift app where you follow all your classes from the beginning to the end. A quick one before we move. Let's get back to class. Enjoy. So the burning of wood, is here a physical change or chemical change? Because see, Jamb always asks this question and people always fail it. That's why it is so annoying, because the questions are cheap. Burning of your matchstick or wood is a chemical change. By the time you are cooking and you are using your wood to cook, right? What do you have at the end of the day? Charcoal, ashes. Can you convert them back into the original wood? It can't. That's why it is chemical change. Because the product that you have obtained, you cannot convert it back to the reactants. Is it making sense now? So in the burning of your matchstick or wood, what happened? Please, it produced two major products. Number one is called heat. Number two is called light. Oh, it produces two major products, heat and what? Light, as well as your smoke and charcoal. And this process is irreversible. So your chemical changes, are they reversible or they are irreversible? Irreversible. And don't forget this, that your matchstick, of course, now when you burn it, what are you going to have? Heat and light, and then your smoke and your what? Your charcoal. Number 8 example is called digestion of food. You take in food ever, you swallow it. It undergo breakdown in the body, and then you now release feces. And of course, during that process of breakdown, what will it give rise to? To give rise to energy. ATP, adenosine triphosphate. Can you combine all of those waste products, the adenosine triphosphate, back to give you your EBA? It's not possible. So what is that? It is a what? A chemical change. Now don't forget this. There are enzymes in the body will act on the food and break it down into what? Simpler what? Substances. And how do they carry out that? Your food is broken down into your what? Your simpler substances. And at the end of the day, you are going to get what? Energy in the form of ATP, adenosine triphosphate. Number 9 example is called combustion process. Combustion is also called burning. And the burning of coal, let's say coal, for example, what will it result to? It will generate heat, light, and gas. Heat, light, and gas. And this is what happens there. This guy is carbon, and that carbon there is coal. Right? When you burn it, what are you going to get? Carbon dioxide gas, heat, light, and then gas is what's given at the end of the day. Number 10 is what is called your smoldering of phosphorus. Follow me from here. Anytime they ask smoldering of phosphorus in exam, people always fail it because they don't know what you mean by smoldering of what? Phosphorus. What do we refer to? Phosphorus has the ability to react with air, and then it will produce new substance and heat. And how will that occur? Phosphorus is reacting with oxygen to give me P4O10 at the end of the day. Please, your smoldering of phosphorus, is here a physical change or a chemical change? Chemical change. Number 11. Number 11 is the solution of active metal in cold water. You know, when we get to electrochemistry, I'm going to explain this. When we get to electrolysis, we'll also explain this. Dissolution of active metal in cold water. Now, what happens is this: when your active metals, such as your potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, AO, copper, mercury, silver, and gold. These are list of metals of the activity series. In other words, the first 3 members of the activity series, like for example, your potassium, your sodium, your calcium, right? They have the ability to react with cold water to produce hydrogen gas. In other words, let's say your sodium is reacting with your water, cold water. What will it produce? Sodium hydroxide and what? Hydrogen gas. This is a chemical change. If it were to be potassium, what will it give rise to? Potassium hydroxide and what? Hydrogen gas. It is also what? Chemical change. Are you with me? Number 12 is called the passing of steam over red hot iron or coke. When you take your steam, right? Steam, this guy here is your steam, gas, over what? Red hot iron. What is it going to give me? It's going to give rise to Fe3O4 and what? Hydrogen gas at the end of the day. So, passing of steam over red hot iron is a good example of chemical change. Or your steam over coke. This guy here, carbon, is acting as the coke. And then you pass your steam over it. What is it going to give rise to? CO, carbon dioxide, and what? Hydrogen gas. This is a good example of your chemical change. All of these are exam questions. Another example, number 13, is called slaking of lime. Slaking of lime. Slaking of, how do you slake lime? Of course, very simple. Your quick lime, CaO, react it with water. What will it give rise to? Slake lime. The formation of slake lime is you allowing your quick lime, CaO, calcium oxide, to react with water, and it will give birth to calcium hydroxide. And calcium hydroxide is called your what? Your slake lime. Number 14, very fast, is called heating limestone. What is the formula for limestone? If I nod you, what is the formula for limestone? Limestone is your calcium trioxocarbonate 4, CaCO3. When you heat it, that means decompose it, what will it give rise to? It will give rise to quicklime, CaO, and your what? Your carbon 4 oxide. This is a good example of your chemical change, because you cannot combine these two products back to come and give you the what? The reactant. That's why it is a chemical change. Number 15 is called passing of steam of hydrogen over heated copper 2 oxide. The steam of hydrogen. Now this is it. Your hydrogen, you are passing it over heated copper 2 oxide. What is it going to give rise to? Of course, it will give rise to your copper, and what? Water is going to be formed at the end of the day. Are you with me? This is a good example of your what? Your chemical change. And then number 16 is adding water to calcium carbide. Adding of water to calcium carbide. In other words, when you take your calcium carbide, CaC2, and you add water to it, what is it going to give rise to? It is going to give rise to your what? Your slake lime, CaOH2, and your what? Your C2H2. Come. This C2H2 that we have here, what is it called? This guy, C2H2, it is called your ethane. What is it called? Ethane is the name. Ethane is the name. In other words, one of the formation of ethane is what? Action of your what? Your water over your what? Your calcium carbide. Of course, you are going to get 18 from there. Number 17, we are going all the way to 20. Action of acid on metals, or action of acid on trioxocarbonate 4, or what? Alkalis, which are the base. Now, what happens here? This guy here is your metal combining with your HCl acid. What is it going to give rise to? Your zinc chloride, and then your what? Your hydrogen. Chemical change. Or the action of your trioxocarbonate 4, which is your calcium trioxocarbonate 4, on your acid. What is it going to give rise to? Calcium chloride, water, carbon 4 oxide. Chemical change. Or the action of your sodium hydroxide, right, on your what? Your hydrochloric acid. Of course, it's a good example of neutralization reaction. Now listen carefully, because it's an exam question. Your neutralization reaction, how do you obtain neutralization reaction? It is the reaction between an acid and a base. Sodium hydroxide here is the base. HCl is the acid. What will it form? Salt and water. Sodium chloride, salt, and this guy is your what? Water. So neutralization reaction is a chemical change. And then number 18 is called charring of sugar. Charring of, how do you char sugar? To char sugar means to burn sugar. And how is the burning carried out? By dehydration. You are removing water from sugar. Can I give it to you? What happened is this. This guy is your sugar, right? Yes, C6H12O6. If you add concentrated H2SO4, it will dehydrate that sugar, and then you are going to have black residue in the form of carbon, and then your what? Your water is removed. So dehydration of sugar is also charring of sugar. What will it give rise to? Of course, chemical changes it. And then number 19 is called fermentation of starch to ethyl alcohol. Oh yes, by fermentation of starch to ethyl alcohol, what happens? This guy here is your what? Your carbohydrate, right? Yes, or like something like your starch. If it's undergo fermentation, what are you going to have? This guy is your what? Ethanol, and your what? Your carbon 4 oxide. Chemical change. And the last but not the least, number 20. What is number 20 called? It is called redox change. So redox changes that occur in electrochemical processes or electrolytic cell, whether electrochemical cell or electrolytic cell, all of those redox reactions that occur. When they say redox reaction, it is your reduction and your what? Oxidation reaction. We are going to explain all of these things in chemistry. So your redox changes in electrochemical cell or electrolytic cell is a good example of your what? Your chemical change. So these are 20 examples I've given to you under your chemical changes. And all the Jamb questions are inside here. All the WAEC questions are inside here. If you get this very quickly, let me show you just one little thing you should know. Take note of this, that chemical changes are permanent. And because they are permanent, they are not reversible. The one that is reversible is your physical change. So chemical changes are irreversible. That's why they are permanent. And they involve significant energy changes. Did they involve energy changes or no? They involve energy changes. And they are often not easily reversible. Aye. If you get this very quickly with me, guess what? This is everything about your chemical changes that you should know. If you see any exam question here, the truth is that you're going to blast all of them very easy and direct. Guess what? In the next class, I'm going to see you in the next class, which is our lesson 2. And in that lesson 2, I'll be taking you around everything about your physical changes. I'll see you in class. See you there. Bye-bye. Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the LearnLift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.